Good morning, everyone. Today we shall discuss the topic large language models and chatbot. I'm Dr. Sanchita Naha, scientist in the Division of Computer Applications, Indian Agricultural Statistics Research Institute. So let us start with the core concepts of a large language model. So the name itself defines all the meaning one by one. So let us start with the model. What is a model here? In case of large language models, the model term represent a deep learning algorithm, but these algorithms are specific in performing multiple natural language processing tasks. When we talk about natural language, we are basically trying to mean the languages that are generally spoken by human beings to make themselves understand. It could be Russian, it could be English, French, or our regional Indian languages like Hindi, Marathi, Bengali, etc. And based on this kind of natural languages spoken by human beings, what are the tasks that are important for a computer to perform so that it can be called intelligent? First of all is understanding the natural language, because when we speak something, the other human being, based on the context, our expressions, they understand the intent behind what we are trying to say. But the same thing, same task is quite difficult for a computer algorithm to understand. So understanding natural languages is a difficult task, and with the help of LLMs, this can be performed. So we are talking about this kind of complex natural language processing task. Another task is language translation, like English to Hindi translation, Hindi to French translation, this kind of multiple language translation. Then text summarization and text generation. These days we have seen multiple softwares. If we give them a prompt, like give me a poem, write a poem for me, write a draft a email for me. So the computer algorithms these days are so sophisticated, they can generate a huge text based on the prompts given by the user. So this kind of tasks are called text generation. So how these models are able to perform all these operations? So first thing is this kind of large language models. When we talk about models, so there is not one model, there are multiple such models which are specific for different tasks. This kind of models, they primarily use the transformer architecture. So before coming to the large language model, or before we try to understand the large language model, we need to have clear concepts of deep learning algorithms, little bit of a transformer architecture, all these things. So primarily they uses the transformer architecture, and they are trained on a huge number of large data set. Now when we are talking about large, we need to have an idea how large means, how large it is. So if we consider the GPT model, let us suppose the GPT-3 model, generative pre-trained transformer. These models are used for the most famous application called ChatGPT. So how large data sets that they have used? Generally, it is said that GPT-3 is trained on so much of data that if a human being tries to read that data, that much equivalent amount of data, non-stop for 24/7, for a human being to, it will require 2600 years to finish that much of reading that much of data. So you need to understand how big the data set is, or the amount of the data is behind training one individual large language model. Now these LLMs, they are basically composed of multiple neural network layers. So when we said that LLM model, behind the LLM model, it is basically a deep learning algorithm. Behind these algorithms also, there are simple multiple neural network layers, and all these layers have different functionalities. So we need to have a basic understanding of all the neural network layers, what are their specific actions are, and how they transform the input to the output. Okay, each layer is provided with some input and they produce some outputs. So what is the specific function of a layer? We need to have clear understanding of all those layers. Then there comes the embedding layer. There is recurrent layer, feed forward layers, and attention layers. So multiple or different large language models are made of different combinations of this kind of different layers. Another concept I will throw in along with LLMs, that is a multimodal LLM. This is also in very much in use today. So what does this multimodal represent for? So when we talk about multimodal, this is basically that the models are capable of processing and generating outputs that span multiple types of data, different data types. It could be text, images, audio data, or video data. We have seen the application of OpenAI's DALL-E. DALL-E is a software that can generate images from textual descriptions. If I ask my computer program that draw me a Durga Puja scenario in front of a Roman architecture. Okay, so these things generally don't exist in real world, but the computer has understood, or this has computer programs has that much capacity that it can imagine way behind and way forward and can generate such kind of data. So basically it is processing the text data and it is generating the output in a image format. So different formats of data is used here. So this kind of LLMs are called multimodal LLMs. So DALL-E is one such application where you can see the application of multimodal LLMs. Then there are GPT-4 version and GPT Omni version. You can see in ChatGPT. These are also able to process multiple data types. Okay. Now let us come to the origin and history of LLM. So suddenly LLM has become a huge buzzword once the ChatGPT has came into picture. But let us go a little behind and let us understand that where the inventions came from. Okay, so the origin of natural language processing, it came in the era of 1950s when Sir Alan Turing, he first time proposed the concept of artificial intelligence, which is basically to make a machine intelligent. Okay, but how do we evaluate that whether machines are truly intelligent or not? So there came another concept of a computational linguistics. That means if a computer is able to understand natural language spoken by human, and it is able to generate, also able to generate human languages that once again human beings can understand. That means understanding natural language and generating natural language, and if the computer programs are able to carry out a conversation with human beings, then we can say that they are computationally, linguistically, they are intelligent. Okay, so from there this concept of natural language processing came. And the problem of natural language processing at its inception, it was mainly on, the focus was mainly on machine translation. So there was one particular language spoken and we wanted to convert that language into another language. Okay, so the developments went like that first of all there were statistical models. Okay, then the statistical models were later on converted to neural network models, and then came an era of pre-trained language models. What were pre-trained language models? Where the models are specifically trained where it can understand the input, and the generation part, that means I told you there are two portions. One is to understand the natural language and the second one is to generate natural language. So this pre-trained language models, after the neural language modeling, when they came in picture, they were able to understand the natural language, but they were not so good in case of generating this kind of languages. Okay, because what happens in case of generation, if they are neural network based or RNN based for that matter, so the texts were generated serially. So suppose there is one word and then there is this one word is fed to a large language model, and the model will produce the next word, and when this combination of two words are fed into the model will once again produce the third word. So if it is done serially, so you are basically looking at a computer screen and it is generating word by word, so it will take a long time for the computer program to write even 10 sentences. like that. Okay, so when this processing, this prediction problem, instead of serial processing, they became parallel. That means it is generating parallelly. That was the main game changer for natural language processing task. And this happened at the year after the year 2017, when in the year 2017, Baswani et al. They first time introduced the transformer architecture. Okay, so we will discuss about this kind of architectures in detail later on. So to talk about the origin and history, we can say that NLP models have evolved from statistically rule-based models to neural language models, and from neural language models to pre-trained language models, and from pre-trained language models today we are standing at with large language models. Okay, so as I have told you in the previous slide, that large language models are, that is not one model, there are multiple models. So most famously used models are like BERT, bidirectional encoder representation from transformers, that's what BERT stands for, and GPT, generative pre-trained transformers. They have leveraged the transformers architecture to achieve the state of the art results. Okay, so to understand a large language model, let us not diverge into all sorts of model, because the architecture in case of different models are different. So we need to be model specific when we try to understand LLM. So let us just be specific to GPT, generative pre-trained transformer. So if we want to understand GPT, we need to understand the three terms separately. First one is the generative. From generative, we can understand that the computer program or the model, it has the ability to generate new coherent text based on input prompts. That means what we see in chat GPT is simply basically users are giving some prompt to the computer program, and the computer program understands your prompt. You can change the language while you are giving this kind of prompts. I can write it in Hindi, that draft me an email for tomorrow's meeting, or give me a meeting scheduler so that I can send it to my colleagues. This kind of prompts a user can input. So the model behind ChatGPT, which is GPT-3, 4 or anything, will read the text, understand the text, and based on that text, they will predict a huge chunk of text, or as per your requirement, it will generate some text which is contextually relevant to the prompt given by the users. That means it can generate some new text. That is the idea of a generative, in case of GPT model. Now comes the pre-trained. What we try to understand by pre-trained. First of all, in case of large language models, I have already told you that these models are trained on a huge data set, and how it is very computationally intensive. So every time you want to do some task, whether it is machine translation, suppose there one model have been used to translate one language to another language. Suppose it is English to Hindi. So somebody has developed a LLM where the model can translate the English sentences into Hindi sentences. Now I want to once again convert English sentences into Bengali sentences. So will I do the training process from the beginning? I don't need to do that. With the LLMs, they are already trained on a huge data set, and there is the scope of fine tuning, which is you can use the already trained models. That means pre-trained models, and you can fine tune the parameters according to the task you have at hand. Now, if I talk about what kind of task by fine tuning we can do it. One is your machine translation. As I have already told you, from English to Hindi, if it is given, I can fine tune the pre-trained models in a way so that it can translate the English sentences into, for example, some other language. It could be Bengali. Then there is text generation. If my model is trained in such a way that it can generate some text in Hindi, I can fine tune the model with some more relevant data or some more domain data, and then make it specific to generate some more text in any area that it was not trained before. So it is already trained, but the scope of fine tuning is still remains there, so that we can extend the capacity of a model to do some more tasks. And these tasks include machine translation, text generation, question answering, and then text summarization, speech recognition, all of it. Okay, so this is basically the meaning of a pre-trained large language model. Now coming to the transformer. So this transformer is basically, it is a type of neural network architecture. It was introduced in 2017 by Baswani et al. In a paper called Attention is All We Need, which it relies on the self-attention mechanisms to process and understand sequences of text efficiently. What is core to a transformer architecture is an encoder-decoder architecture. So what happens is, suppose we are talking about machine translation. So there is English languages, English words, they are given as input to the transformer, and within the transformer there is something called a encoder block. So the encoder block will basically transform the English language into some encoding. Let us think of it as a mathematical encoding. It has transformed into some sort of encoding. Now this encoded form of the input is given once again to the decoder, where the decoder understands the output language. Suppose I want to convert my English sentences to Hindi sentences. So the decoder understands the Hindi language, and the encoded sentences are given as the input to the decoder, and the decoder transforms all of it into a Hindi sentence. So what goes inside a transformer architecture is basically an encoder-decoder architecture. Okay, so pretty much this much to have an idea about the generative pre-trained transformer. Now let us understand that using this kind of LLM models, how this GPT model, it is able to generate text. So suppose this any user has given a prompt to a large language model, like, can you generate a paragraph on artificial intelligence? This particular prompt is fed to large language models. As you can see, this large language model has different layers to it. So the first layer will try to understand that what the user wants with the prompt that they have given. Okay, so the first layer will do only that much, and the second layer will now process it further. Okay, so for every response generated, ultimately in the output layer, for each iteration, so the entire output, if it is a output of 10 sentences, and each sentence is having 10 words, that means 10 into 10, 100 times the LLMs will run. Okay, so each an individual word will be predicted by the LLM at each iteration, but these iterations will happen parallelly and so fast that the user sitting in front of an AI assistant won't even know that these are happening one by one or parallelly. I mean, how fast it can happen. So what the large language model will do, it will basically predict that what will be the next word following the follow the text that we need to generate. Okay, so this kind of lists will appear. That suppose let us talk about that AI refers to the simulation of human intelligence in machines designed to think, comma. Now what will be the next word after the text has generated up to think, the model has generated up to think, what will be the next word? So for each word, the model will predict the probability, that what could be the best probability for learn to fit there. As you can see in this particular case, the probability for learn to be the next word next to think is the highest. Okay, so accordingly these large language models are basically making the entire text coherent and context specific. Okay, so this is a very rough idea of large language models basically work. Okay, now let us understand, because I spoke about that in the first layer. So the large language models will be having multiple layers, and I told you in the first layer it will do the processing of understanding the input. So how it will understand the input, let us see here. First of all, let us see if it's a input in embedding. That means for each and every word that is given in any particular language, it has to be converted into a numerical representation for the machines to understand. So from this sentence to word, from documents to sentence, sentences to words, and from words to their dense vector representations, this is called the input embedding. Now, how do we imagine this? If we can imagine like this, suppose this is a particular sentence: the quick brown fox jumps over the lazy dog. This is a sentence, and this kind of multiple sentences are merged into a document. So once we convert one single document, suppose a PDF of 2 pages, if we convert it into the input embedding, it will be a highly dense multi-dimensional embedding vector of this kind. Okay, and this will make the first layer in the neural network architecture that we have already I told you earlier. Now the question is, for each and every tile or each and every dimension of the vector, what is there in for a one dimensional? So suppose if I see this the, it is embedded with every vector that is there. What is there in this particular tiles? There remains basically numbers, decimal numbers, which are also probabilities, or we can say decimal numbers like 0.4, 0.6, 3.8, like that. So how those numbers are generated? Basically, to understand the context of the input that has been given by the user, multiple questions are asked against each and every word, and the answer to each question basically makes the this vector. So if the first question asked is whether this word belongs to English language, if it is yes, it goes to 1.0. If it is not, then 0.0. So likewise, in case of English, if we have 9 languages or 10 languages and we ask the question if it belongs to any particular language, then for that particular language we are giving some probability, and for the other languages we are giving some less probability. So this is one type of a question that you can ask the user prompt given by the user. And there are multiple such questions. So how many ever questions are asked to this particular sentences, they basically make up the input embedding vector. Okay, so we will come back to the previous slide. So that is how input embedding converts the words into dense vector representations, and it also includes the positional embeddings to maintain the word order. That means in case of LLMs, the identification of the context is also important. Sometimes in a sentence it is given like look at the river bank, and in other sentences they are referring bank as a financial institution. So the words before and after a single word set up the context for the entire meaning of the sentence. So before bank, if they have used the word river, that means it is trying to mean the river bank. But in case of a transaction, a word transaction before or after a bank, it will mean the financial institution as bank. So this kind of positional embeddings to understand the context, these are also captured in a large language models, all by the representation of this vectors only. So once this input embedding is done, then there is multi-head attentions, because the LLMs are based on the transformer architecture. So what happens in this multi-head attention? It captures the relationships between the words regardless of the distance. Okay, distance here we mean once we plot this dense vector representations in a 3D or a multidimensional space, the distance between the words when they are related, they are shown. Okay, so this kind of relationships are captured in a using a multi-head attentional neural network, and it basically enhances the understanding of complex text structures. And after this embedding layer is there, then this multi-head attention layer is there, then there is feed forward neural networks which processes the informations and it generates some intermediate representation. So I told you ahead that to understand a large language model in detail, we need to have a clear understanding of all these layers, how the attention layer work, how the feed forward neural network work, and then there comes the output layer which predicts the next word or sequence of words, and it uses the softmax activation. So basically you can see for this previous slide, we are basically predicting the probability for each and every individual word to be the next word. That means kind of in a way this is like a multi-class classification where we are attaching some probability to multiple class levels. We can think of it as multiple class levels. So in the output layer, softmax function can be used to associate some probabilities with each and individual word. Okay, so once this is done, this is somewhat regarding the architecture, and these are the major companies or organizations they are involved behind the buzz behind large language models. So for the GPT series, the OpenAI company, which are pioneers in generative AI, then most of the freely available LLMs to experiment with, they are given by Google, which is BERT, T5, Lambda. They focus on searching and conversational AI. The models that I spoke about for given by OpenAI, they are not available for free of cost. Mostly they are licensed. And then there are other models called Llama, which are given by Facebook or the Meta company nowadays called. They are focusing on open research. And then OpenAI and Azure AI services, they are given by Microsoft, and Microsoft has invested heavily in OpenAI. So basically the GPT series is a product of Microsoft only. And then there is another company called Hugging Face. It is basically a hub for open source models and tools like Transformers libraries. This particular hub is having a huge collection of LLM models that are freely available. So you can download these models and use it, or fine tune it rather, to do multiple natural language processing tasks that I earlier spoke about, which is whether it is text generation, summarization, speech recognition, or machine translation, anything. Okay. Then what are the successful applications of LLMs that are there? There are chatbots. So with LLMs, because they are able to understand and generate text, application of LLMs have been, we have seen it in case of making a large number of chatbots for customer care services like ChatGPT. It has made the most amount of buzz around. And then for content creation, it is very useful, whether if you give a prompt to generate an article that has skipped marketing copy or some creative writing. So content creation, this can be done using large language models. There is large language translation. An example could be Google Translator. This Google Translator is also using large language models for accurate multilingual translations. Then there is assistance in coding. These days computer programs are so sophisticated that they can generate computer codes for multiple tasks. Okay, this kind of tools are available in case of GitHub, Copilot, all these things. Then there comes education, assisted in personalized learning, content generation, language tutoring, all these things. And then search optimization. It improves the search engines by understanding queries better and delivering relevant results. So let us understand now a chatbot a little bit. Chatbots are basically, they are called conversational virtual agents. They are called virtual because in reality they don't exist, but they are basically computer programs or applications or systems, we can say, that has been designed so that they can simulate a conversation with its users being the human users, and they obviously leverage different large language models to understand and generate natural language responses. So in case of development of a chatbot, there are mainly two components. So one is the natural language understanding, and the second one is generation. What happens in case of understanding is chatbots use large language models to comprehend user inputs in natural language, identifying their intent, what are the entities involved in the user prompt, and the context of the user who is asking the question. And in case of generation, once again, LLMs, they excel in natural language generation. And this is how they enable chatbots to create contextually appropriate answers in real time. And there are different types of chatbots. From the perspective of development of a chatbot, it could be a rule-based chatbot. So how does it operate? So if a chatbot, if a user is giving some prompt that do this for me, then you take it in a rule-based construct that if this prompt is given, then generate this output as a response. So this kind of rule-based strict chatbots are there, and then there are AI-powered chatbots where dynamic responses are given to different users, and then there are hybrid chatbots also, and also based on the specific task what the chatbot can perform, they are different. Like task specific chatbots where you communicate with a chatbot to achieve some specific goal. Suppose if I have a computer program and I'm asking that program to set an alarm for me for today. So whatever today, tomorrow, or for the entire year. So whatever conversations I'm having with the program, that will be only around the specific goal of setting up that alarm. So these are called task specific chatbots. And then there are domain specific chatbots also, that within that particular domain you can ask any question to the chatbot and it will give you appropriate responses. So this is one chatbot that we have developed in-house. It is called the Dairy Shriya app. The Shriya here stands for Smart Heuristic Response Based Intelligent Agent. So for this Dairy Shriya, we have a mobile application, also a web application. So this is one of its kind first chatbot that has been developed for dairy animals. This particular chatbot is able to respond to cow and buffalo queries. They are available as a Android-based application in Google Play Store. This particular chatbot is also developed using another LLM, which is the BERT I discussed earlier, bidirectional encoder representation from transformers. So using the same methodology, we have developed two more chatbots, which is one for sheep and goat Shriya. So basically we have collected around 40,000 question and answering pairs for different animals, for cow, buffalo, sheep and goat, and we have another chatbot which is a swine Shriya. So for every bot that has been developed, we have collected question and answer pairs, and these questions are fed into the BERT model to generate the encodings, and these encodings are then used for the to match the query question similarity. So basically whatever questions we have within the database, they are their corresponding their corresponding embedding vectors are matched with the query that is asked by the user, and the most similar query and the most similar answer to the query is then given as a response to the particular user. Okay, so and to understand LLMs and chatbots better, I have listed a few references that can help you get better understanding on all these topics. So these are the few references you can follow for future learning. So for a simple and introductory LLM and chatbot related concepts, that was pretty much from my side. So thank you.